Well, we're so lucky to have with us today Ali Javidan. He is the CEO and founder of Range Energy. Ali, thanks for joining us. And please let everyone know, what is it? Because I see a big truck and I see a battery and I see a motor. It's very exciting. But tell us what's going on here.
Well, what you're not talking about is basically what the entire industry has been being left behind in this entire, this big decarbonization struggle. You missed the most important element in your description, is the trailer.
Interesting.
And so, if we think about this for a moment, everything that's being developed is working to make what's in this box move more efficiently, add telematics and sensors so that we know what the temperature is or where it's located, or if it's a box full of GPUs, how to lock it out and how to do this and that for security and all of this stuff. And well, as we continue to throw technology at either the infrastructure side or the tractor side or the truck side, the box that's actually doing the work of holding the goods is being left in the dark. And so this was it was kind of an aha moment that I had back in 2021. So long story short, almost 30 years in automotive development, spent the first 10 years of my career building fun race cars.
You worked at Tesla, right?
Yes, exactly. And then in 2008, I transitioned out of the motorsport industry into Tesla. I was early in the company, part of the original R&D team. And when Elon joined the company, he cleaned house and focused the company on two things. One was shipping Roadster, and two was here's a very small team put aside to develop what could be the next vehicle of the future, the sedan that we wanted. And back then we called it the White Star. And so I was put in charge of the platform prototyping, or the vehicle prototyping, and worked very closely with the design team, Franz and his team, as the company was developing the Model S. And I got to play a role in the development of the Model S all the way through the factory handoff. From there, I went to Google in 2012, worked on a bunch of fun projects there. And then 2015, I kind of put the best of all of my favorites together, robots and cars, and went to Zoox and helped work on the Zoox Robotaxi, and again, did the vehicle prototyping, and in fact, all the prototyping for the company through 2021. One common theme in my entire career, my entire life, frankly, has been I've always been around trailers. Just weirdly enough, I've always been around trailers. Well, growing up, my cousin's the same age as I am. He grew up on a farm, and my favorite thing to do when I was 12 or 14 was go out there and hook up a truck, hook a pontoon boat or one of the farm trailers up to a truck and go just practice backing up and driving around. So it's always been something that's, when I was at Tesla, I was the first guy to drive a truck and trailer there because, it was a bunch of engineers and really nobody had much experience, towing things. So when we were going on tests, I was the one driving the truck and trailer to the test. So this has always been something that I've always been nervous of. And if you've ever towed anything, even with your bike, towing your cousin on their skateboard, you know how nerve-wracking that could be. Now imagine you have this system on the road, a big rig that's 80,000 pounds in many cases, and this little 15,000 pound tractor. We don't see it as little, but it's really in that equation a little element. That 15,000 pound tractor is meant to carry the load of the 65,000 pound box behind it. And the box has no intelligence. And so this is the premise here, is that, well, if we can relieve the safety anxiety that we have while towing, and we can make the driving experience better while towing, could we also extract efficiency? Because now the box is doing its own work. And then to extend that, but knowing what I know about the trucking industry, is that change is very challenging, and everything that's being proposed to the trucking industry is really focused on the primary mover or the infrastructure. Both things that are very expensive and very challenging to change. But they buy these trailers every year. There's 3.5 million of these trailers in the United States, like just the big rig Class 8 trailers. And they're, replacing them about 10% every year. And so what if we were to start to electrify those trailers as they get replaced? Well, actually, even better, what if we could retrofit every one of these trailers that are on the road today? And that's the premise of Range, is we've developed a nominally sized energy module that houses a battery pack and an e-axle, and that essentially clips in underneath the standard 18-wheeler trailer that you see driving around, whether it's refrigerated or non-refrigerated. And we now deliver a power platform that has never existed before. And you can do all kinds of things with this power platform. And by that, I mean, well, we can use the e-axle in conjunction with the energy module to drive the trailer, to actually help it propel itself. what's the result is that a diesel tractor that would normally get 6 or 7 miles per gallon is now getting 12, 14, in some cases up to 18 miles per gallon. It's incredible. And if you have an electric tractor, all these photos of the poor electric tractors stranded on the side of the road because they run out of range. Well, now you can get 250 or even 300 miles of range on your tractor that would maybe get half of that if you're lucky when you hook up to one of our trailers. And so it's really this enabling device that thinks about how does the industry work today? We don't want to disrupt anything. There's no new interface, no new wire connection. It's just hook up and go. Everything is self-contained. It only takes a few hours in a yard to install it. If you unfortunately decapitate a box or something happens to the box and it gets damaged, the same day you can actually pull this kit out and put it in a neighboring trailer and get that trailer back on the road and decarbonize your fleet in a massive way. But we also save with anti-jackknifing algorithms and regen algorithms and all of these other things. So that's the long story long on my background and what we're doing at Range.
All right.
That is really cool.
So let's talk about the trailer, I guess. I mean, it's definitely the thing that you think the least about when you think about trucking. It's always the truck, the guy in the truck. But you're talking about the trailer, and so I think for a lot of people, you see them on the road, obviously, and maybe you work somewhere where a guy drives a forklift into one and pulls stuff out. But not too many people are going underneath the trailer unless it's an action movie, and then they just, but no one's really talking about all this extra space, but then also any kind of controls. I know that there's hoses. I see obviously they have to hook up some brake lights. How does your system interface with the truck? Because I'm sure the truck doesn't have any kind of smarts to be like, trailer, quickly, give me some more power.
Yeah, does the truck have to have like a special module in it?
No, that's a great question. So we thought about all of those things at the beginning, but since the 60s, the early 60s and late 50s, the interface that the truck and trailer has not changed. It's essentially the glad hands, which are 2 air lines, and a pinned connector, whether it's 4 pins or 7 pins or whatever. And that barely delivers enough power to drive the lights on the trailer and really nothing else. Knowing this and knowing that there are a million tractors on the road, some of them, I'm a trucking fan, so I like those long hood Peterbilts and those really cool, like when I drive through Texas and Arkansas and I see some really, truckers that are really proud of their rigs. I don't want to rip those things away from them. It's like somebody pulling my old BMW away from me. I don't want that. You can make it better. You can make it run much better and have less stress as it's towing these big boxes that I'm being asked to tow. You can make it safer for me. You can make it get better gas mileage. I'll take all of that. Just don't take it away. And so thinking like that, we could not rely on a connection between the tractor and the trailer to make our stuff work. We rely purely on physics and modern day sensing. So we have a series of sensors on the trailer, on our system, that sense in real time what the driver's intention is. And I say it very specifically like that. We're not trying to predict or guess. We're actually measuring and responding. So if the driver is pulling through an intersection up a hill and needs to get through that intersection and their foot is mostly on the floor, we could actually sense that. And we start to fill torque in between the shifts so that they get a steady push through the intersection up that hill. In fact, we do that so elegantly that most drivers say that you just turned my truck into a hybrid electric. It feels like a sports car now. And we've actually had documented routes coming in 30 minutes faster a day because they're able to just accelerate up to speed along with traffic.
I saw that. I saw quotes on your website from truckers saying that they actually felt everything was smoother, getting on highways was faster. But like I even saw a video on your website of your testing in winter conditions in Michigan.
Yeah.
And I mean, it looked like 2 different experiences.
Yeah, talk to me about how that works, because I mean, I get the concept, right? Like electric motors. I drive a Tesla. I've driven electric cars. I get.
Have you ever ridden an electric mountain bike or electric bike before?
E-bikes, all the different kinds.
So pedal assist. All we're doing is pedal assist here. So you don't have a data connection between your legs and the bicycle, but that specialized knows how to assist you to make you feel like a superhuman, right?
True, but this is way more complicated because this is a trailer that might not necessarily be pointed in the same direction as the truck. So how do you make that? So like, let's say I'm a trucker and I'm accelerating, but then I want to make a turn. It seems like if the trailer just starts flooring it, that I could very easily jackknife, because it would just kind of, I would
100%.
and then it push me into a crazy jackknife. How do you prevent that from happening?
In the same way that our phone can tell whether it's laying down or sitting up or like this, we have the same kind of IMU in our system. And that IMU can resolve not only direction, but intent very, very well, along with a couple of other sensors that we have in our system. We're able to see what the wheel motion is. We're able to see what the vehicle motion is, not only fore and aft, but in every single axis in every direction. And we actually are measuring the dynamics as they're happening. A little secret that I'll let you into is I used to be a vehicle dynamicist. Part of my race car thing was actually building systems like this and building suspension systems. And we have, I would say, one of the most sophisticated platform kind of chassis teams here on site that's working through this to make sure that driver confidence is priority, and then efficiency gets extracted from there. And part of that is never feeling like that trailer is taking control of you. I mean, that was one of the fundamental things I learned as a race engineer, was if you as a race engineer make the driver as confident as possible, they will extract the best performance out of that vehicle. And so that's what we're doing here. So if you are turned, for example, going through an intersection, we can actually see those very, very slight movements of the trailer that they're getting turned or tugged. And we've got 200,000 miles of classification plus. We have many more than that in simulation. But we have many miles on the road that help us kind of confirm these algorithms and all of these different states. So far, and that's why we've been so aggressive with our both summer and winter testing, is to push the limits as hard as we can of this system to make sure that, number one, we are driving and we are delivering safety and convenience, and then we start to extract efficiency from there. We will never, ever put a driver or anybody around that vehicle in an unsafe state in the name of anything else. So it's safety is priority.
A while back, you said two magic words: regenerative braking. That's one of the reasons I love driving a Tesla, is like I never put my foot on the brake, hardly ever. Yeah. It sounds like, is this something you can offer truck drivers now?
Absolutely. So that's one of the biggest features. In fact, on a typical daily route, you're familiar with a refrigerated trailer, has that little kind of that refrigeration unit scabbed in the front of the trailer. Those are burning diesel constantly, between 1 and 3 gallons an hour, average about 2 to 3 gallons an hour, just sitting there keeping the box cold.
You're saying, like, if I'm a truck driver and I have to stop for an hour to get food or sleep or whatever, that like I have to keep my truck running?
You have to keep the little diesel generator that's sitting in the bottom of the, there's a complete another engine in the front.
Oh, I didn't know that.
Wow.
Yeah. And so there's noise restrictions. There's no catalytic converters. There's really no emissions controls on those engines. And so in different regions, especially in places like California and Washington and other places in New York, those refrigeration units are becoming outlawed. So this is another benefit of our system. But the best piece is that just in a standard daily route, we generate enough energy in just regen to power that reefer unit. So even if you don't have any charging infrastructure and you just go drive on your route, we will put enough energy, reclaim enough energy to run the reefer unit and your lights and your lift gates and all of that stuff.
Electric vehicle drivers know what regen braking is like and what it feels like and what it's doing, which is actually putting energy back in the battery of your car so that you can then use to drive some more. With a truck, it's actually a little bit more important because, I mean, I've seen those runaway truck ramps on the highways, you know, when you're going through the mountains and you're like, oh, what's that big gravel ramp? You know, is that a place for me to go park? No, don't do that.
And they are terrifying if you've ever seen them in person. I've seen them in person. And I've actually, you know, going down big grades like the Grapevine or coming down Mount Shasta or some of these places, or, you know, one route that I used to do all the time is from Reno back to Sacramento. And, you know, you're looking for those runaway ramps. You're hovering on your brakes, all of that. I'll tell you the experience of our system. You're at the top of the hill, and because you're on a route, we know what your state of charge should be based on the lane that you're in and all of that stuff, the route that you're running. At the top of that hill, you set your speed. Let's say the speed limit is 55 miles an hour. You start down that hill at 55 miles an hour. You either set the speed with the engine brake or with the friction brakes or whatever, and the regen kicks on. As soon as you let go of the brakes, the trailer does everything that basically turns the axle into a generator, puts the energy back into the battery pack. And the best of all, this is what's doing the braking. And if you're doing the braking from the back of the trailer, you have a balanced system. The tractor, when you're going down the hill and you're braking from the front, this trailer is freewheeling and wild. Yeah, there's brakes back here, but the performance of this system, the old disc or drum brakes that are actuated by air, like, it's not even in any passenger car system in the world, right? And so our e-axle can modulate, in many cases, an order of magnitude faster than what the foundation brakes can do. So a lot of the times we are actually outperforming the braking system, the foundation braking system, and never even getting into ABS when we get into these critical situations.
Because again, I think a lot of people go like, oh, but they're just brakes. And it's like, yeah. And if you pull up to a stoplight, they just slow you down. And that's not a big deal. Yeah. But when you're going down a gigantic hill, you want to take, it's just physics. You want to take something that weighs 80,000 pounds and you want to make sure that it doesn't end up going 400 miles an hour at the bottom of the hill, ignoring aerodynamics. You need to put that energy somewhere, and you're going to turn that all into heat, put it right into the brakes. And the brakes are not made out of adamantium. Yeah. They are made out of normal everyday materials and steel and
heat soak, and the brake pads melt and the brake fluid melt. Like it
fails. Like it starts to fade and then it fails, and then all of a sudden you start accelerating down the hill, and then you need the truck ramp that's made out of gravel that hopefully stops the vehicle without killing everybody on the highway.
That is the type of thing we're focused on, is safety and drivability first, and then the efficient.
But with your e-axle, it's not doing the same thing. I mean, it's generating energy, but that energy isn't heat. It's electromagnetic, and then it turns into electricity, and it goes into the battery as chemical energy, and then you have a cooling system that's going to keep it, but most of the energy is getting stored.
That's right. And the best part of it all is that when you need the brakes, it still has the standard trucking brakes back there. Right. So everything is still there. Even the same brake pads that you have on your shelf, we deliver that fancy e-axle with the same wheel ends that all the fleets already use. So we're not forcing or asking for anybody to change anything dramatically about their operations, because that's critical here, is that I can't present a new piece of technology that forces a fleet to dramatically change how they work every day. We charge off the loading dock. Part of the reason I did the trailer was because the trailer is the only asset that's meant to be parked. Everything else needs to be moving to make money. The trailer has to be parked to get loaded and unloaded. So can we charge at that same exact time? And in fact, yes, we can. So now we're basically transparent to charging. And guess what? If you think about a large fleet, about 200 trailers on there, actually, that is a very small fleet. A large fleet would have 2,000 to 4,000 trailers. A medium-sized yard with about 200 trailers. So 200 trailers on a yard is 8.8 megawatts of on-demand surge capacity. In that one yard alone, that's almost $2 million in annual revenue just playing the capacity markets while your trailers are parked in.
Whoa, wait a minute. Holy okay, wait. So you're saying
all of our trailers ship with two-way power. We are mobile infrastructure.
Oh, okay. All right. So talk to me about the battery size then on these trailers. I'm assuming they're, whatever the customer wants, but how big can we get?
It depends on the application and all of that stuff. Our the first SKU that we are shipping for the refrigerated trailers is 300 kilowatt hours. For a non-refrigerated trailers is 200 kilowatt hours. These are LFP cells, and they are meant to last many, many cycles. They're very safe on the roads. And essentially the idea here is that, the decarbonization and the fuel savings is just the thing that's there to pay for this equipment that then ends up unlocking a huge opportunity in power infrastructure, in mobile data infrastructure. Think about all of these new technology providers, Samsara, Garmin, all of these guys that are trying to get telematics onto the products that are moving, Amazon, all of them. The trucks are being instrumented, the yards are being instrumented, the boxes, the trailers, there's no power. There's no data. This is lift gates. This is real, mission critical equipment that runs off of 12 volt infrastructure that we just take away. And now your lift gate runs off of 48 volts. Eventually, when you work with big partners and they can run all the way up to 800 volts on our system. So we have a full bus voltage, full power system that can provide everything from small power for sensors all the way up to the big power for the e-axle.
Oh, that's sick.
So, okay, so let's just talk about that for a sec.
So we get it, but that's because we've been doing this for 10 years and we're just barely getting it. Can you explain that to the layperson who might be listening going, what are they talking about? What are they getting so excited about? So when you do vehicle to load, we understand the arbitrage here, but maybe can you put that into layman's terms?
Yeah, I mean, we all know all the buzz around some of the products that like Ford's been putting out. For example, the Ford F-150 hybrid that has the two-way power that becomes backup power for your house. Or, the extension of that is like the Tesla Powerwall. One of these trailers is like deploying 22 Powerwalls at once.
And so you're getting into grid scale sized things here. I mean, you're talking megawatt stuff.
There are 3.5 million trailers, Class 8 trailers in America, in the United States. If we were to deploy this technology, it would be 1.05 terawatts of mobile storage. And that is distributed on demand, literally anywhere you want it, that has a surface that you can.
This gets into the fun parts around having batteries, which is that you can now store energy, which traditionally the grid has.
You can plug your solar panels into it too if you're doing stationary work.
And I mean, we've heard from all sorts of different companies. There have been school bus companies that said, we make electric school buses. Now, when there's a power outage, the school can run off the school buses. We've heard from electric train companies, and they said, we can move electricity from a solar field to somewhere else.
But now imagine you have a warehouse full of vaccines, and that warehouse is insured for $500 million.
Yeah.
And you run out of power, and your old Kohler generators or brand new Kohler generators are not allowed because you are at the Port of Long Beach, for example, or something like that. I'm making things up. Well, just the trailers are already plugged in, getting charged. When the power goes out, you just put into your fleet tool that you actually need the trailers to now feed power to keep the building alive. And it's all controllable through a very simple fleet tool that the fleet manager has.
And you're making a decentralized power storage system.
It's making the grid so resilient.
I mean, you could very much help a lot.
1 terawatt hour is pretty. It's a pretty good number.
I don't know if we've come anywhere close to that right now. I think we're maybe in the gigawatt hours, but I mean that's three orders of magnitude larger.
I mean, you've already sold us. Like, we want to have a fleet of them now. But
Sure.
let's go back to the independent truck driver or the smaller company. Can you give us some numbers? So, like, if I get some of these, what are they going to do in terms of, I don't know, how much fuel savings am I going to have?
We kind of break it down into the things that the fleets care about, and it's cost per mile and ROI. When am I going to pay this thing off, and how much is it going to save me per mile? Our current baseline, based on the averages of pilots that we've run with large fleets, all the biggest names and a bunch of the smaller names as well, we are averaging somewhere around 17% cost per mile savings just on the fuel offset, including all the maintenance costs and the charging costs and all of that stuff. So 17% is a significant number because that's net. We're not saying we're saving you 3% fuel economy because then it all washes out into 0.5% of net savings. We are slashing cost per mile by 17% net. That pays for the trailer. That comes out to being somewhere around $30,000, in many cases $40,000 a year. So it's averaging right now to between $35,000 and $40,000 a year in savings. That goes on for as long as you have the trailer in service. That's, over 1 million miles or whatever our lifetime is. This essentially pays for itself in less than 3 years. So, you have an asset on your yard that's lasting you 12 years. You're 9 years of $40,000 a year in benefit. And don't forget, this is a software-defined vehicle. When you guys find an efficiency in your fleet and we kind of roll it into our algorithms and find another 2% of fuel economy, everybody's going to get that. All the trailers that have our system will get that. So we are going to be flexing that software-defined vehicle element here to make sure, and only for the reason of continuing to provide the fleets with the most flexible and robust tool that we can.
I know this is a hard one because it hasn't happened long enough for insurance companies to evaluate it, but we kind of are starting to see it with Tesla, where they've got their own insurance company and they're able to start passing those savings on to customers because they realize, oh, we can see how much safer these cars are. Is there a hope that your trucks with these trailers could be safer on the roads and therefore get a lower insurance rate?
I'm going to make a very shameless plug. Go to our YouTube channel. We have a few safety videos. We have a winter testing video and a summer testing video. That is absolutely my intention here. Our intention here is to dramatically increase roadway safety with this technology. We have a huge opportunity to reduce jackknifing, rollovers, increase braking performance. Our winter test video shows that we actually almost match the performance of a 2025 Dodge Durango on all-season tires on the ice, and we're on regular truck tires. So we have a loaded truck and trailer on the ice, doing a full ABS stop, pretty much matching the ABS stop of a brand new SUV. And so that's like 30 or 40 feet shorter than it would have otherwise.
So talk to me. So there's kind of two big aspects then I'm hearing, which is braking performance, which the faster you can stop the truck, the less like you are to slam into something. And then there's the jackknifing performance. How does the jackknifing performance work?
Yeah. So just real quick on the braking performance, and then that'll kind of lead into how the jackknife performance works. So the braking performance, the reason we're able to outperform the baseline brakes and ABS so well is because of our ability to modulate torque in real time using the e-axle is so much higher, multiple orders of magnitude faster than the kind of stack up of all of the pneumatic systems that actuate these mechanical brakes. So we actually have a lot more resolution around wheel slip and controlling wheel slip. And that's how we're able to increase braking performance.
Because essentially you don't want to lock up the rear brakes, because then what you'll see that thing in the movie where the rear like locks up the back thing, and then you just see the back of the trailer just slide across the highway, and then
it's like, the way that I say it is that, like, imagine, I don't know if you have a big brother, pretend like you have a big brother, right? And they're pushing you from behind, and you're trying to stop the whole thing, and then all of a sudden they're like, nah, I'm going, and they come around you. That's a trailer and a truck every single day. That trailer will win every time. But because we're able to sense that wheel slip much faster and sense it and then respond to it much, much faster, we're able to kind of pull that tire into that static and kinetic friction domain, going back and forth between the two and modulating in, very, very quickly. And that's how we're able to fundamentally increase the braking performance. So it's always just about to slip or just slipping and sensing. But then we use that, we couple that with the IMU, the inertial units, the gyros or the accelerometers that we have in the trailer, we can actually start to see when the trailer is going to roll over in a high-speed turn, for example. We can actually start to see when you're starting to reach the limits of tires. And this is without instrumenting the tires. And as we start to see that, we start to gently apply, I don't want to call it a negative torque, but almost a tensioning torque to the system to essentially build a stable, long, stable system. So it's almost kind of like you have, your skis, right? Imagine if you had a lot of bite in the front of your skis, but no bite in the rear. What we're doing is adding a lot of bite in the rear. And then all of a sudden your control goes way, way up. And that's how you're able to prevent jackknifing and rollovers and all of that stuff.
Let me get this straight. So, this is like, when we're talking about driving, this is like, we're at the limits of driving because it's the limits of the tires.
That's right.
So you're saying essentially that the ABS, like when you slam on the brakes in a car, and hopefully most people don't do this that often, or they don't do it on slippery surfaces, you'll feel that like shudder, and you'll be like, why is it shuddering? And that's because it's like applying and letting the wheels slip a little bit more, so that way you're not just skidding, like it's Blues Brothers. You're actually controlling, and that's what anti-lock brakes are. So you're saying the finer resolution that you have at the rear, instead of the trailer going like brake and then it having to send pneumatic braking information, if you even want to call it that, all the way to the rear, which could end up with essentially locking up those rear tires or not applying enough braking force.
There is ABS in the trailers, but it's very rudimentary and it's controlled essentially pneumatically, and it's relatively kind of, it's pretty much open loop. It's like, oh, everything's fine. Oh, everything's fine. There's no like, let's kind of like tread through the forest and see how this goes. It's like everything is dead or everything is totally fine.
You're eking out a lot more traction out of those rear tires, and that's going to be able to, and then you throw into that what you were talking about with the IMU, and then all of a sudden you can save a jackknife from happening.
That's right. We can actually sense it in many cases before the driver even notices that it's happening and correct it. Our drivers even said there's been a few times where he didn't even know it was about to happen, but we fixed it. And so I definitely compel you guys to go look on that Range Energy YouTube channel and look at those winter tests and summer test videos. It's really, really telling, and it kind of gives a little bit of insight on how we're able to extract this type of performance by focusing on the trailer as a stability platform.
Now, you mentioned that you have a SKU that's already shipping, that you're already producing.
So we have a handful of prototypes and test trailers and pilot trailers out. We officially start production at this time next year. So essentially the end of 2026 is when we start production and do our first customer shipments. We will start doing volume shipments at the beginning of 2027. And in fact, we already have our customers all lined up for most of the first year of production. And if a couple of our orders go through, then our first few years of production will be called for.
I was going to ask you if there's truck drivers watching, if they want to call you, but it sounds like they better get on that list fast.
I'll say one thing about truck drivers. I love seeing that, hey, so-and-so just got 92% better fuel economy and so-and-so just got 18.7 miles per gallon and all of this stuff. The biggest compliment that I hear is, for example, last week from a massive fleet. This is a massive, massive fleet. Hearing from the feedback from the VP of Sustainability that the way I know that this is going to work is that every single morning the drivers are arguing over who gets to take your trailer out. And we've had 200 independent drivers interact with our system, truck drivers, 100% driver satisfaction. And as my systems engineer, Colin, says, is show me another thing that 200 truck drivers can agree on.
Right. I mean, this reminds me of the Tesla Semi where people, at Pepsi and Frito-Lay and stuff, where all the truck drivers are trying to get in the Tesla Semi. My question for you is, it sounds like this would actually work with the Tesla Semi.
Yes. I can't say too much, but it definitely, this will work perfectly with eCascadia, Tesla Semi, electric Volvo, any of those things. And we do truly believe that at some point in the future, we will have some type of alternative power unit, whether it's electric or hydrogen or whatever. I personally feel like it's probably going to be electric in the long future, but it'll take a while to get there. I want our system to work today, 20 years from now, 40 years from now, because I know that once these fleets start to rely on this, not only to help with driver and safety and efficiency, but now you start talking about mobile infrastructure, then these things are not going to go away. And I want them to work no matter what that mode of propulsion is up front.
So I have two kind of questions that it seems like you would run into issues with. And the first one would be truck driver backed up a little too far into the loading bay, smashed the back of the trailer. It's no longer roadworthy. You got this battery, you got this axle sitting there, and they unload most of the stuff. Some of it's broken, some of it's not, whatever. But now what do we do with this trashed up trailer?
The most likely it is the box and or the chassis of the trailer that gets damaged. Our system, the axle is 4 bolts and a few connections, and the energy module is a forklift and 2 guys and a couple of impact drivers. And within 8 hours, you can actually have that system completely out of a crashed trailer and functioning and running in the neighboring trailer. 2 people, 8 hours, 1 forklift, same tools you have in your toolbox.
So somebody's
that was
probably still getting fired, but most likely,
Maybe.
Do you think that the guys that are working, loading and unloading, they have a forklift and
Yep.
they probably have an impact wrench or 2? Do you think that it would be up to them, or are you going to send out, a range energy guy?
Yeah, so that's a wonderful question. There's a few different ways of doing this. Fundamentally, and kind of the biggest initial way is that we have a dealer network. That dealer network are folks like Thermo King dealers, Sonsray, stuff like that. These dealers will be taking and installing our kits, maintaining them, managing them, all of that stuff for us in the field.
So this is sort of your everyday truck kind of stuff.
That's right.
There's stuff
right.
always going wrong on tractor trailer trucks.
That's right.
And this is just going to be more of that.
Yep, and we're going to provide all the tools that are needed for diagnostics and all of that stuff on site and in the field, but also all the training that folks may want about safety and all the other elements. And then we're going to have a team of field engineers, kind of like the original team of Tesla Rangers that was made from a bunch of my old vehicle techs in the Tesla days. And we will have a series of field engineers that are going to be a mix of technicians and folks that are experts in documentation and quality, and they are going to be around at all the different install sites to make sure that there's success with the customer. The other way is where fleets actually have their own infrastructure. So there's, there are bottlers around and other folks that they have their own service folks. They may use a dealer to do the initial deployment, but then they'll have a service bay in-house where they'll be doing the swapping around. Beyond that, there's just a bunch of different flexible ways of doing this. We have friends at the Goodyear service network. We have a bunch of different folks that we are working through to figure out. Ultimately, it is how do we remove friction from the customer? I want this to just be a quick decision and then just a whole bunch of smiles. As my buddies at Myers Make say, smiles for miles. That's it.
So then I guess my other question would be, for every pound of batteries that you're putting in this trailer is like a pound of potato chips that you can't be driving around the country. How impactful is this? Because I know that 300 kilowatt hours, it's heavy, but it's not like insane.
Doesn't DOT give you like some offset that you can use because it's electric?
Yeah, there are a couple of weight allowances depending on the states and the routes and things like that. And some of those weight allowances more than cover the system weight that we have. Our system weighs around 6,000 pounds, depending on the battery capacity that you choose. That's, less than 10% of what usually is what could be in the box. But all of that being said, in practice, every day when you come home and you get a box of air from Amazon with like a pencil in it, that's what's in most of these trailers. And so about 75% are what is called cubed out. They run out of volume before they run out of mass allowance. And the ones that aren't, well, guess what? Because we're measuring kinetic energy and we're reclaiming kinetic energy, the heavier your load is, the more efficient, the more we can actually help with decarbonization. So actually most of our first customers are the ones that typically load out. They mass out over cube out. And this is the food and beverage folks. This is like all the refrigerated fleets, but the efficiencies, the safety, and the convenience of being able to run everything off of pure electric is so high that even in the few cases where one or two folks are like, we got to take one pallet out, they're still more than happy about everything. And so far, nobody has had to make any major changes to their fleet in a negative way or any negative changes to their operations to make this all work.
That's so interesting. I mean, I remember, and you don't have to weigh in on this, but I remember the engineering explained video where he was talking about the Tesla Semi, and he was just like, oh my God, it's going to be so much heavier and they're not going to be able to tow anything. But I mean, it's interesting to hear you talk about 70% of loads being cubed out.
So Jason Fensky is a friend of mine, and so him and I have talked about that video, and we have talked several times about other things too. And so I think what he puts together is great and brilliant, and I can't wait to provide him some data for him to revisit the truck and trailer electrification set of equations.
Ali, as we wrap here, people watching who might be interested in investing, I know it's a private company right now, but are there any chances down the road that you guys might go public?
I think there definitely could be that opportunity. I think we are taking it day by day, month by month, quarter by quarter. It really just comes down to how successful we are with the market and really what the appetite of some of the partners are. I don't have a target on this company for an acquisition or anything in particular. As I said, from the very, very first seed round investment conversation that I had with, my friend Tyler or Adam, my intention here is to put the most advanced and safest trailer systems on the road possible. And by advanced, I mean customer experience. And so this really, ultimately, if I can ship these trailers and it means that we go public, it means we stay private, it means we sell, whatever it takes to get this technology on the roads, in drivers, into the fleets, and eventually boat trailers and all of that other stuff too, right? We have a huge, huge opportunity to electrify all the trailers. Towing sucks. Let's not make it suck anymore.
That's awesome. Thank you so much. I have one last question that is kind of the far-flung future, and that would be around, I mean, it sounds amazing that you have all of this sensor suite that can detect all of these problems. Do you ever foresee kind of plugging in the trailer to the truck so that way when the driver hits the accelerator pedal, you're not necessarily always relying on inertia, and you're going to be able to give kind of instant torque? And will that provide any benefits, or do you think there's never going to be a day that you're going to need to plug in the truck?
There definitely are some benefits, and there are some regulations, in fact, in Europe that require that conversation to happen. The challenge is that governing bodies like the SAE and the rest of the industry don't seem to be converging on a communications protocol and or standard that matches the demands of today's fleets until at least 2030. Like literally, they said, we're not even going to talk about this and finish this until 2030. And so for us, I would love to have access to the data because it'll just make everything a little bit better. But we would also not be able to ship if we had to rely on that data. There's a whole functional safety domain that if we were to rely on that, then that one data transmission pipeline becomes a single point of failure, and then the redundancy falls. And so there's a whole bunch of stuff where we can use that data to enhance the performance, but we can't rely on that data pretty much ever.
That makes sense, right? If you cut the cable, which it's on the road.
Yep.
So it definitely seems like you're always going to have this system at least as a backup. But it's cool to think that someday we'll actually have smart trailers.
You know what I think we should
have
do?
them now.
I think we should go visit him with our solar trailer and force him to install it.
You're not the only one who's got a trailer with a battery in it.
Come on down. Yeah, we're in Mountain View. We're in the middle of Computer History Museum's right behind.
That'd be awesome because I feel like
right
we could talk
behind
to you
us.
all day. Your experience and your background is amazing. I'd love to talk to you just about your Zoox years. That would be.
Oh yeah, that's it was really, really fun times there. I get a really big kick out of bringing things to life and to market that just nobody had ever even thought about would be possible before.
That's so exciting. Thank you so much for being you. Thank you for doing what you're doing, because I think you're going to make the world a whole lot better, a whole lot safer. I can't wait to check back in with you, hopefully in a year or so when things are actually shipping. That'll be really exciting.
I appreciate that. Yeah.
Thank you so much, Ali. We'll see you soon.
Thank you, guys. It was good to meet you.